To find the surface area for this frustum, we're going to extend those two segments down, and the total surface area then is the lateral area of the big cone minus the lateral area of the small cone plus the area of the big circle on top plus the area of the small circle on the bottom. To find some of these lengths, we're going to need to look at the cross section. We have this right triangle, angle of 70 degrees. The next radius is drawn in. That angle is also going to be 70 degrees. We have a radius of 6. This length is 16. Now, in order to find some of these lengths, we're going to have to use SOHCAHTOA because we have a right triangle with an angle given to us. I'll call this length x. And then relating the 70-degree angle, the length of 6, and that x together is going to be cosine. The cosine of 70 is equal to the adjacent of 6 divided by the hypotenuse of x. And then when you solve this for x, multiply both sides by x, divide by the cosine of 70. So x equals 6 over the cosine of 70. That is about 17.54. And we're going to need to use that, so go ahead and store that as alpha a. Once you know x, that will help us find this length, which I'm going to call y, which is the slant height of the small cone on the bottom. Y is equal to alpha a, because it's the entire length, that's that x value, minus 16, and that's going to be approximately 1.54. And I'll store that one as alpha b. We already know the radius for the big cone. We don't know the radius for the small cone yet, so in order to find that, we're looking at just the triangle at the bottom. We know we have a 70-degree angle. This length is stored in the calculator as alpha b. I don't know this radius right now, but what I can do is use cosine to find it. I'll call this alpha c for right now. The cosine of 70 degrees is equal to alpha c over alpha b, that's adjacent over hypotenuse. Multiply both sides by alpha b. And here's what alpha c is going to be equal to. That is approximately 0.53. So now that I have all of these values, we can plug this into the formula to find the total surface area. The lateral area for the cone on top is going to be pi times its radius of 6 times its slant height, which we have saved as alpha a, minus the lateral area of the small one, that's pi. Its radius is alpha c, its slant height is alpha b, plus the area of the big circle, that's pi times the radius of 6 squared, plus the area of the small circle, that's pi times its radius of c squared. So there's everything in the calculator, and when you plug it in, it gives you an answer of about 442.09 units squared.